Okay, so this week, either on Thursday or Friday, depending on which of my classes you're in, so it's Monday or Tuesday, here's what we did. We went over just briefly, don't forget you have a 1-point assignment on communications. That's just so I can know what's the easiest way to get in touch with you. Wow, good job, Perkins. Sorry, that was sarcastic. Baby Seal says hi. Then we went over exponential versus power functions. There's a Desmos graph that you guys can kind of play with to look at that, but I'm going to go through the notes for that in just a second. Then we're going to review the rules that we learned on Monday or Tuesday, and then we're going to learn what do you do with this, and how is this green function different than this one, and FYI, your mid-quarters are due next Friday. Just so you know, here's our plan before winter break. This is what we did on Monday. The end of the week, we did exponential properties number 2 and the exponential and power graphs. On Monday or Tuesday, depending on when you have me in class, I'm going to introduce the project that y'all are going to work on, and you'll have some time to work on that. The next Wednesday is a regular, so this is like a no school day. So no school. This is a time for you guys to work, and there will be office hours. And if you want to make an appointment with me, hours, you absolutely can. Next Thursday or Friday, you're going to meet with counselors, and we do not have a regular math class. I'm going to do some support for your project here. Your project's going to be due on Wednesday. We'll do a thing on logarithms, and then you have winter break. Hooray! Okay, and then exponential versus power functions. I had you guys play with a graph that looked kind of like this, and we all just kind of noticed things about them. Y'all said if k was 1 here, this would be a straight line, that it bends sometimes. At k equals 0, the graph goes flat for the orange one. Sometimes we got 2 lines. The left side was moving up and down. So play with this graph. There's a link that you guys can actually go back to that. And before we get to the actual definitions, it's important to know that when you have a number like this, where it's some number with an exponent, we call the big number here the base, and then the tiny little number an exponent. So in this case, 5 is the base and x is the exponent. And what we found after playing with that Desmos graph is that exponential graphs either grow or they decay. And all of the equations look like y equals some number to the x, and it's important to note that the exponent is the x. And if it looks like this, where it starts out kind of flat and then it goes really high, then what we know is that the base is more than 1. So for example, this could be the equation like y equals 4 to the x, maybe minus 1 kind of thing. So the base, this 4, that's the base, has to be a bigger number than 1. And then the x, of course, is just an exponent. For exponential decay, the base has to be between 0 and 1. So maybe this equation was something like y equals 0.5 to the x, and then plus 3. That plus 3 just kind of moved this up. The minus 1 just kind of moved this one down. But again, the base is between 0 and 1. The exponent is an x. The base here is more than 1. So that was exponential graphs. For power graphs, what we found was that all of these, it depended if the power was even or odd. If it's even, you ended up with the sides of the graph would match each other, and it could look like this, where it was broken into kind of 2 pieces. But on an odd graph, one side would go up, one side would go down. So this side goes down, this side goes up. And in each of these, the base is a variable. So this is an x, here is the exponent. So in this case, they would both go up, where here I have a negative 3. In this case, one of them would go up and one of them would go down. So then in class, I asked you to kind of identify which. And so here were examples of power functions, where you have a base of x, and then the exponent is a number. So the exponent is a number, the base is an x. For an exponential function, the exponent is an x, and the base is a number. So 4, and I know E seems kind of like a strange thing, but E is about 2.71, just kind of like how pi is about 3.14. E is a special number, so this is like 2.71 to the x. Then we did some review, and you guys learned on Monday or Tuesday, this is just kind of review, that if you had a base with an exponent and the same base with that exponent, if you expand that out, so here's 2 factors of k and then 5 factors of k, that what you end up doing is basically adding those together, because written all out, I have 7 factors of k. We also reviewed that anything to the 0 is 1, no matter what that thing is. If you were dividing same base, different numbers, what you'd have is you'd have this many over this many, and as many as you can, you're going to simplify. And just like how multiplying 2 exponential numbers led us to add, here if we divide 2, that's like subtracting. So you had 5 to the 4 minus 7, which is the negative 3, or 1 over 5 cubed. And then anytime we have a negative, we saw that we could move that to a denominator. So this is like 1 over p squared. Then we kind of looked at, and again, we used Desmos for this. So by all means, go to Desmos and plug in these graphs if you need a reminder. But are these the same thing? And what we found is that over here, wrong thing, sorry. What you'd end up getting here is this is like having a negative, and then the 2 is only with the x, so that's 2 factors of x. Here, the 2 is with all of the x squared, so this is like negative x times negative x. And what's really important here, because I do have 2 factors of x, and I have 2 factors of x here, but here I have 1 negative, and here I have 2 negatives. So this graph is negative x squared, and this graph is positive x squared, because those 2 negatives multiplied together get a positive. And so these are not the same graph. So these are not the same. But if we had a third or an odd number here, we found this was like negative x, oops, wrong color, negative x, 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 and this was 1, 2, 3. Here we have 1 negative, and so we're going to end up with a negative answer. And here I have 2 negatives make a positive, but then multiply by another negative, and you're going to get another negative. And so these actually are the same. This is like negative x cubed equals negative x cubed. Here, we're going to end up with the same kind of problem, though, where I have 1 negative here, so this is going to be negative x to the 4th, because it's equals negative 1, 2, 3, 4. And then here we would have negative x, negative x, negative x, negative x, and here we have 2 of these would make a positive, and we would end up with a positive x to the 4th. And so in the end, we found if they're both positive, or both even, then they were going to be different, and if they were odd, they would end up being the same. The idea being that we just kind of have to pay attention. Is this exponent with the x, or is it with the whole negative x? And then the last thing is, what do you do if you have like 5 factors of 3 to the 2nd power? And this means that you have 2 of these. So we have, in this case, 2 factors of 3 to the 5th power, which we saw before. You could just add these. The other thing we realized was, 5 times 2 is 10. So x to the 3rd to the 4th is like x to the 3 times 4, x to the 12th. Or you could just write out and say, I have 4 factors of 1, 2, 3, 4 x cubed, and we end up with x to the 12th. Either way, you get the same thing.